Hey pre-algebra kids, this is lesson 18 in your pre-algebra book. We're almost done. The first thing we're going to do with this lesson, as the objective is to write equations from verbal descriptions. So that's the first thing we got to do. Here's some verbal descriptions, and we're going to write an expression that matches them. And then we're going to explore solutions for equations. Basically saying, is a statement true or is it false? So first of all, let's go through these examples on the board. I'll read it out loud for you. What I want you to do before I even write down what the answer is, I want you to try, and then I'll wait a couple seconds and write it down, and you see if you got it correct. So here is A. The sum of a number and 6 is equal to 24. Try it yourself. One more time. The sum of a number and 6 is equal to 24. You should have written x plus 6 is equal to 24. And to make this really clear, I'll start using a different color so that you can really see it very easily. X plus 6 is equal to 24. When I'm doing these, I don't know if it'll help you at all. I'm always looking for the unknown because that's where my variable is going to go. So like the sum of a number, we don't know what the number is. That's your x, and we know it's a sum, so we're adding. And 6, oh, we do know what that one is, equal to 24. Equal tells us it's going to be an equal sign. All right, here's B. Remember again, try it on your own, and then I will write the answer. A number decreased by 10 is 15. One more time. A number decreased by 10 is 15. All right, so decrease tells you that it's subtraction. You're decreasing by 10, and it's equal to 15. What's your unknown? The number. You don't know what it is, decreased by 10, but you do know that it's equal to 15. C, the number of inches increased by 20 is 50. The number of inches increased by 20 is 50. All right, so again, we're increasing here, so we're adding, and we're adding 20, and it's equal to 50. But we don't know what the number is, so we put x. X plus 20 equals 50. D, the length of a rectangle is 36 inches, which is equal to twice its width. The length of a rectangle is 36 inches, which is equal to twice its width. So big thing here, it starts with a number, 36. Says it's equal, which is equal to 2 times twice its width, but we don't know what its width is. 36 equals 2x. Another way of writing it, 2x equals 36. Both are correct. Lastly, a student is 15 years old, which is equal to his brother's age plus 4 years. Again, a student is 15 years old, which is equal to his brother's age plus 4 years. So this one, again, just like D, starts with our big number, 15. And it says it's equal to his brother's age, which we don't know, plus 4 years. 15 equals x plus 4. Another way of writing it, x plus 4 is equal to 15. Our brain kind of likes this way a little bit better, and most mathematicians would write it this way. This way is a good way of starting because it gives you your equal to first, and then you write it out correctly after you've gotten the answer. All right, so hopefully you were able to do that, as you're going to have to do that in the homework today. And so you'll read a statement just like this and put it into an algebraic equation. Because of the equal sign, these are now equations, not expressions. And then you're going to solve. So now we're going to step over and do the solving portion of this, but first I got to change my screen. So what we're going to do for number 1 is we're going to solve this. We're going to try to figure out what is x. This is basic algebra. This is what you do in algebra. You're given an equation and you have to solve. Well, I have some really neat tricks for this that make it quick and make it easy, and so I'm not even going to kind of do it the way that the book does it. I'm going to kind of take the reins here and show you my way. I think my way is a good way of doing it, and hopefully Mrs. Moorfeld's way is similar to this when you have her next year. So I see that x is not by itself, so I need to get x by itself. That's how I solve for it. If I have x equals something, then I know what it equals. So I need to get rid of the 6. I'm going to do the opposite of what is happening here. We're adding, so the opposite of adding is going to be subtracting. I'm going to subtract 6 from both sides. When I do this, I'm left with, these cancel, and I'm left with x alone. And x is now equal to 24 minus 6, which we know to be 18, right? No. Yes, 18. 18. So x is equal to 18. So there's your first way of solving. What if you have subtraction instead? X minus 10 is equal to 24. Well, very simple. You just add instead of subtract. So you're adding 10 to both sides. Whatever you do to one side, you got to do to the other side. You have to remember that. These two cancel. You're left with x as it comes down. And you get 14 because 24 minus 10, it's plus 10, not minus. Good thing I wrote my workout. See why it's good to write those in. Now I can change it to 34, which is the correct answer. I'm going to go back to my black now because I messed up this 2 here. We're going to talk about number 3 and number 4. So I gave you multiple choice for number 3 and number 4. And I want to see if you can remember which one of these is a property that you've seen before. So some of you may already know, but let's first look at number 3. If we plugged in 70 or 30 or 20, let's go with 20 because 20 is a little easier. Do we get the same thing on both sides? Are they equal? Well, 3 times 20 plus 2 is equal to 2 plus 3 times 20. 3 times 20 is 60 plus 2, 62 on that side, 60 plus 2, 62. Does 62 equal 62? Oh yeah, it does. So we know 20 works. Do you think 30 is going to work and 70 is going to work? They are. All of these are true. And it's because of what property? Can you remember? Well, it's addition. Commutative. Blah, blah, blah. Property of addition. Commutative property of addition. Saying that it doesn't matter what order you put these in. 3x plus 2 equals 2 plus 3x. You could add 5 and 4 and 4 and 5 and you would still get 9, right? It does not matter the order that you add as long as you have the same numbers and they will all equal the same thing. So that is a way of proving why that's true. True because of the commutative property of addition. Now number 4. Let's look at this one quick. Again, I'm going to start with the small number because, well, it's smaller and it makes math easier. If I put 18 in for x, 18 minus 1 is supposed to equal 18 plus 1? Just saying that out loud doesn't make sense, right? 17 does not equal 19. So, do you think any of these are going to work? No. The reason is, one is addition, one is subtraction. They're opposites. Opposites are not going to equal each other. So none of these work, okay? This is just not true. Number 4 is false. All right, so there's some solving, there's some true and false there. Now let's get even deeper into some true and false with 2 more examples. So we're gonna look over here first. You have an algebraic equation. Again, it's an equation because it has an equal sign. And you have a solution. You need to figure out, is this solution true or is it false? How do we do that? We plug it in. So 2 times 4 plus 8 is supposed to equal 16. Let's figure it out. 2 plus 4 is 8. Plus 8. Is 8 plus 8 16? Sure is. 16 equals 16, therefore it is true. This is how you solve. You're going to need to know how to do this for your homework. You're basically going to, like in the first screen, take those algebraic equations and a number they give you, solve it to see if it's true or false. How about this one? A bigger equation, but we can handle this. Let's first distribute and simplify our equation so that way it's not as hard to solve. Well, actually, no, we'll plug in. We won't distribute. Let's just plug in. You're going to plug in -2 for both of the x's. So 6 times -2 plus 4 minus 9 times -2 plus 3. This is supposed to equal 0. Let's solve your parentheses first. Make life a little easier. -2 plus 4 is 2. So now you just have 6 times 2 minus -2 plus 3 is 1. So we can just say that it's 9, right? 6 times 2 is 12 minus 9, which is equal to, well, not 0, right? It's like 7. Am I right? Is that right? 7? Something like that. Anyways, 7 is not 0, or whatever it is, it's definitely not 0, because 12 minus 12 is 0, not 12 minus 9. So therefore, this one is false, and -2 is not the solution for this problem. So again, like I was telling you, in your homework, you have some paragraphs. Don't be scared of them. They are just going to be giving you the word form, and you have to come up with the equation. So start with your knowns, then go to your unknowns and use a variable. If you have questions again, hit me up in the Zoom. Good talking to you. See ya.